Okay, so we're going to look at the final relationship that between gas and now gas pressure and now volume. Temperature and volume. Okay, so the first one we saw, when we decrease the volume, decrease the size of the container, the pressure increases. Second relationship we saw, and this is Boyle's law, by the way. The second relationship we looked at, when we increase the temperature, there's kinetic energy, frequency of collision increases, therefore the pressure increases. So now the third one is, if let's say I increase the temperature, what happens to the volume? So how do we know? I encourage you to do this experiment. Okay, take a balloon, blow it to a not too big of a size. Okay, and then you tie it. Then you measure the circumference of the balloon. What is the circumference of the balloon? Let's say I have a balloon. I measure this. So I take a thread, I wrap it around the circumference of the balloon, and then I measure with the ruler, measure the string with the ruler, and see what's the measurement. And then you take that same balloon, make sure you tie the balloon, okay, but the air is going to come out. You take that balloon and you dip it in hot water. Okay, dip it in hot water and quickly take it out and measure again the circumference of the balloon and see what is the length. Okay, you can pause this video and go and do the experiment first, and then you can come back. But what will happen is, when you put it in hot water, which means when you're increasing the temperature, okay, what happens is, okay, the particles in the balloon will push the balloon as much as they can. So remember, the balloon contains the gas particles. You increase the temperature means that you're going to increase the frequency of collision. They're going to collide with one another. The pressure is going to increase. When the pressure increases and balloon is stretchable, the walls of the container is not like a glass where the glass won't grow bigger. Balloon can grow bigger because it's stretchable, right? So the particles will start hitting the walls of the container. Hit and make it expand and expand and expand because the pressure is now increasing. So you hit the wall of the balloon and it pushes the container, the wall of the balloon. So what happens? The balloon will grow. If you do the experiment, you will see that when you measure it after putting it in hot water, the circumference will be slightly bigger. So what has happened is the volume of the balloon has now become bigger. So when you increase the temperature, okay, what happens is it again gains kinetic energy, frequency of collision increases, and it pushes the wall of the balloon, provided that the material, the gas particles in is stretchable. Okay, what happens is it will hit the wall of the balloon and the balloon will grow bigger. So what will happen? The volume of the balloon will grow bigger. Okay, but let's say you leave the balloon for a while, continue experiment, leave the balloon to cool off for a while, and then you measure again. Okay, what will happen is the circumference of the balloon might come back to the same measurement as what you started with. Okay, now why is that? Because when it cools down, what happens now? The pressure inside the balloon and the atmospheric pressure, the pressure outside of the balloon, that means your room, they are now equal. So no matter how much the gas particles push the wall of the balloon, the same pressure is coming from outside in the atmosphere. So same pressure outside and same pressure inside, so it's balanced, so it will stay. You won't see much of a change. Okay, so the third law is, when I increase the temperature of the gas, the volume also increases. So these are the three main rules or laws of gas that you want to remember and keep in mind. That's all.